Welcome. This is the third video for Unit 2 Worksheet 1, which is dealing with multiple choice, and we're going to finish it off in this video. So we're looking at 17. A vehicle is driven up a hill at a constant speed. Which of the following best describes the energy changes that are taking place? So in this case over here, it's driven uphill at a constant speed. So constant speed, what energy has remained the same? The kinetic energy. But because it's driven uphill, what energy is being increased? It is your EP, your potential energy. Which of the following best describes the energy changes? Well, we probably this one over here, because you've got your chemical energy of your fuel is converted into gravitational potential energy. That's true. But also sound, and also the engine is giving out quite a lot of energy. So that would be the best one there. It is gravitational potential energy, but not all the energy is converted into gravitational potential energy. Only some of it. Some of it has got to, it's going at a constant speed, so it's got to maintain that. So that's going to be giving out friction and so forth. So that would be B. For 18, a rubber ball traveling in a horizontal direction strikes a vertical wall. It rebounds at right angles to the wall. The graph below best illustrates the variation of the ball's momentum P with time when the ball is in contact with the wall. So when we multiply P times T, we see that that would give us our area, and P over T would give the gradient. Alright, so which of the following statements is true? Now, we have got our formula that Ft, the impulse, is equal to a change in momentum. So F over T, P over T, the P over T, change in momentum over time, that's actually a gradient value. That's a gradient value over there, and that's equal to the force. So it looks like the gradient is going to be the force. So the gradient is equal to the force exerted by the wall on the ball. Now, we've got here that this is the ball's momentum. So the ball's momentum is actually being decreased. Now, why is it being decreased? Because the ball is actually has a force exerted on it by the wall, which actually slows it down here and then accelerates it here, causing a change of motion. So this one over here would be the best. Okay, going on to 19. The time taken for a stone dropped from rest to fall vertically 16 meters is 2 seconds. Based on these measurements, which is the best estimate for the acceleration of free fall? So because it was dropped, it says it was dropped from rest, we know that our U is equal to 0. We have our S is equal to 16 meters. We have our time is equal to 2. Which formula would be best? Well, you need to go to your formula booklet. I'm sure you'll all recognize this one, and we'll look for get this formula. S equal to ut plus a half at squared. That's equal to 0. That's 16 is equal to 1/2 times a times 4, which is 2 squared. So a is equal to 8. That would be the best one for that. Alright, let's go over to the next page. Next page. 21. We have which of the following is a correct statement for Newton's second law of motion? A force acting in the body is proportional to the mass of the body. No, it's proportional to the acceleration, isn't it? The mass is the constant of proportionality. The second one, the rate of change of momentum of the body is equal to the net force acting on the body. The rate of change. So rate of change means what? What does it mean? Rate of change. It means this over here. Change of P over T. So, and we know that is another way of writing Newton's second law. So that will actually be the correct one. The momentum of the body is proportional to the net force acting on the body. No, it isn't. It's we can see from this it's proportional to the acceleration. The force acting on the body is proportional to the acceleration of the body. Not always. We have the net force acting on a body. So it would be B. 22. A ball of weight W is traveling horizontally towards a vertical wall. It strikes the wall and rebounds horizontally. The change in the magnitude of momentum of the ball is delta P, which following is the magnitude of the impulse that the ball imparts to the wall. So we have here which following is the magnitude of the impulse that the ball imparts on the wall. Now we know that impulse is equal to F change in T is equal to change in P. That's our formula. So the delta P is the impulse, so that would be it over there. This W is actually a little bit of a red herring. It doesn't seem to affect it because it's going horizontally. That weight there doesn't seem to be playing much effect in this problem here. Going on to our last question down here, I just want to bring it up. We have two objects undergo an inelastic collision. Now, you need to know what an inelastic collision is to answer this. In an inelastic collision, we can have P is conserved, but EK is not conserved. So, which of the following is correct in respect to conservation and the concept of the total energy? Okay, so this is slightly different. The total energy, we would have both of those conserved because the total energy we know will be conserved. The EK will not, but the energy will be transformed into other forms of energy, but the total energy is conserved and the momentum is concerned. So 23B is the correct answer in that case. And so we just go over the page to our final question, and we have this one. It's dealing with circular motion. A particle P is moving anti-clockwise with a constant speed in a horizontal circle. Which diagram correctly shows the direction of the velocity and the acceleration? So the velocity is always at the point of time, so it's actually always, that is your instantaneous velocity. This over here would be your acceleration because that's the direction of the force. Your force is inward over there, so this would actually be the correct one. It would be 24C is correct. Well, I hope those helped you, and if you've got any further questions about these questions, please